Welcome everyone. Laser Dave here from Trotec Laser to go through another exciting seminar. This webinar will include Ruby software training. Today's course will go through the newest version of Ruby 2.6. So if you don't have Ruby 2.6, these are new features and capabilities we're going to be covering today. Today's course is going to be kind of an informative flow-through training course. If you have Ruby or if you're looking to get Ruby, now's the time to go ahead and take a look at it. So this course is going to give you the basic understanding as well as advanced capabilities of the Ruby software. So let's go ahead and move into my screen here and get going. If you have any questions throughout this course, please go ahead and post them, and we will spend some time at the end of the course going through it. I will bring up a live version of Ruby so that I can explain capabilities and features for questions that may not be answered during the course today. So let's go ahead and move forward here. This is Ruby software training version 2.6. Version 2.6 came out about mid-month this month, in the month of June. And it has quite a few new features, capabilities. So all the features shown today will be utilizing this version. So if you don't have the version, make sure you have run that update on your laser system so that you have the latest capabilities. This course does use QR code links. So if you do want to access a lot of the different locations, websites, capabilities, videos and stuff like that, you can scan these QR codes to go to those types of links, as well as web links, download links, and stuff like that. This video is being recorded and will be posted on our YouTube channel so that you can access this at later dates when you need these resources or access to these resources. If you don't already, follow us on our social platforms, your favorite social platform, YouTube, Facebook, Instagram, LinkedIn, Pinterest, and Twitter. We are on all of them. Most of our content is disseminated across all these different types of social platforms. Today's seminar, we're going to go through where to download Ruby, a little bit about job control, Ruby installation, and compatibility. I'm going to go through an overview of the Ruby screens, enhanced benefits of Ruby, a Ruby walkthrough, a simple base, as well as a full flow. And then I'm going to go an in-depth training course through the manage screen, design screen, prepare screen, produce screen, and the main drop-down menu so that all features, capabilities, and modes are covered and explained. And then I'm going to go through some frequently asked questions that are commonly asked to showcase some of those questions, and then some advanced Ruby process videos. So things that I don't actually cover in the actual main training, we'll go through and kind of give you links to those type of advanced features that we may not cover today in today's courses. And then some Ruby help links. And then finally, at the end of the course, I will answer all your questions, what's possible if we have enough time. And then we will conclude this course for the day. Okay, for Ruby, if you don't already have it, or if you want to download it, here is the download link. If you go to ruby.troteclaser.com or scan this QR code, it'll take you to the Ruby download page. Current supported laser machines is the Speedy 100, 300, 360, and 400, as well as the SP 500 laser machines. Coming soon is the Rayjet 50, R400, R500, 1500, 2000, and 3000 SP model laser machines. And that will conclude most of the actual flatbed laser machines that are supported for Ruby by the end of 2024. Like I said before, this version is 2.6 in this version. Now, please understand, if you are a job control operator and you're still dabbling whether or not you want to get to Ruby, you can. Something I wanted to make sure everyone understands is that you can run job control and Ruby simultaneously. They can both be installed on your laser system. So as you're learning the Ruby software, learning all these new capabilities and features, you are going to have the ability to jump back and forth to job control for those features you may not know, or maybe you're more comfortable with until that transition has happened. So make sure that when you download Ruby, you don't have to worry about running all new software all at once. A little bit about job control support life. I get this question all the time. Is it still supported? Stuff like that. Job control is still supported on most of our laser machines, unless you are running what we call a run-on Ruby laser machine, which has the onboard computer. Those systems only work with Ruby. Job control is not discontinued as of yet, as we still have models that are still running job control. However, as the final versions are reverted to Ruby, job control will eventually be discontinued. This does not mean job control will stop working on your laser machine. What it means is that you will not be, job control may not be compatible with future software and computer hardware updates. Future Windows operating system updates won't be compatible. So if you do continue to want to use job control, that's fine. The difference is you want to make sure you keep your hardware and your software the same on your computer, and that job control will work indefinitely. In addition, as job control is phased out, factory support will become more limited as fewer people use it, fewer support staff know it, as it is an old software. The other thing with job control you need to understand is there's no new features, capabilities, or improvements being added to it. Besides, say, bug improvements and stuff like that, that is about all it's being modified and updated on job control. And that is the benefit of going to Ruby. Ruby is now just over 2 years, or will be 2 years old, July 15th. It has 8 versions. It's growing in features, updates. It's updated about 4 times a year. And it's free. It's faster, easier, and far superior than job control on most metrics. Ruby is about 10 times faster than job control, and laser jobs can be taken from a design file from a design file folder to operational on your laser machine in as little as 10 seconds. So all that time that is typically run processing through job control is now eliminated when using the Ruby software. Something I didn't mention on the previous slide too is the Speed Marker series. The Speed Marker series will also be upgraded to Ruby eventually, but that is going to be probably last. You're probably looking, I would estimate, probably late to 2024 for Speed Marker softwares. Now, once you download Ruby onto your system, if you want instructions on how to actually install it on your laser machine so that everything is done correctly, here are QR code links for the Ruby instructions. So if you scan this one to the left here, the QR code will actually walk you through instructions on how to install it, make sure it's set up correctly on your laser system. Secondly, the question is also typically there are what we call certificates that need to be installed. Ruby is a network-based. It doesn't work on the internet. It works on your local network. And so it needs to have an installation of what's called a certificate. And there's a video here that's going to actually walk you through how to install it on Windows, as well as instructions on how to install it on a Macintosh. Compatibility. Now, if you are running an old laser machine, that laser machine will need to be plugged into a computer, and that computer will need to be Windows. Any run on Ruby machines or any additional computers will run on any operating system, which means if you have 10 computers in your office and you have a run on a Ruby machine, those computers can be any operating system: Windows, Mac, Chrome, iOS, Android, Linux. You can run it from your phone. You can run it from your Mac. It does not matter because it is a web-based or a network-based driver. It eliminates the need for a specific operating system. So if you do have an older style, that system will still need to have Windows on it like it does now. But additional computers within your local network can have any operating system on it, meaning you can actually run your existing older laser machine with additional operating systems from other computers within your network, running any operating system like Mac, Chrome, iOS, Android. You can look at it from your phone just by typically logging into the web link within the that is identified, which we'll cover later. So why do you need Ruby software? Ruby software is a daily workflow that basically it improves the overall process of your laser machine. Simple and quick workflow from idea to finished product. Platform that guarantees profitable order processing, networked, web-based, and fully digital setup. User interface that delights, so that basically it has it all. Anyone can use it on a network. It doesn't matter what operating system it is. Any computer can be sent to the laser system. You can run it from your graphics, from any of your existing graphic software. You can run it directly from Ruby. It just adds. It takes away, actually doesn't add, it actually takes away the complexities of prior problems that laser systems have had. So that is the benefit. I was an early adopter of Ruby, have kind of warped into it right from the beginning, and I am definitely an advocate for it. It is far superior in most every metric to any other software I have used. I've used all competitive software. It is so far ahead of those that it just makes the process much more simpler in the operation of your system. So I'm going to give you a quick Ruby operational walkthrough here. First thing is just to give you a basic overview of Ruby. For those of you that may not have seen Ruby before, maybe you're just deciding maybe I want to still upgrade or not, this is just going to be your basic walkthrough. For Ruby operation, turn on the laser, place desired material into the laser, and then focus. Open the Ruby software. If the file is complete and ready to be processed, select the design file from another screen or folder and drag the supported design format directly into the Ruby Prepare screen. Then use the red dot pointer or the overhead camera shown here to position the graphic onto the material. Select the material from the materials database, then push the file to the laser and press start on the laser to process the design. Another process for Ruby is to use all 4 screens: the Manage, Design, Prepare, and Produce screens. Start in the Manage screen. Drag the design file in or select the Import button shown here. Select a compatible file and open that file. Select that file from the Manage screen list to open the Design screen. The Design screen allows for files to be created or edited. In this example, I will add text to the graphic. Adjust the text size and snap it to the box center. Once editing is complete, select Create Job. This will take the design into the Prepare screen. Use the red dot pointer or overhead camera shown here to position the graphic onto the material. Select the material from the materials database, then push the file to the laser and press start on the laser to process the design. Ruby is an advanced laser workflow software that provides, in many cases, all the graphic tools you need to create designs, graphics, photo, and text elements, preventing time-consuming switching between laser software and design software, especially when making adjustments to design or laser jobs. Ruby software seamlessly works with files created in popular design software such as CorelDRAW, Adobe Illustrator, AutoCAD, as well as SVG, EPS, and PDF vector formats, and non-vector formats such as JPG, PNG, and BMP. When files are loaded into the Ruby software, errors are automatically detected and fixed, optimizing them for the laser machine, including line thicknesses and colors. While Ruby software does not replace advanced graphic software packages, it enables users to quickly adjust imported designs when necessary, eliminating the need to switch back and forth between different software packages to make multiple file adjustments. This significantly streamlines the design process, saving time and effort. The workflow leads you step by step from the idea of a laser job to the finished end product, like this bamboo wood gift box. Okay, that is a basic overview of it, kind of exactly what Ruby does in its very basic form. So for those folks out there that are just getting started, it is that simple. You can literally drag your graphic in that you've created in your CorelDRAW or your Illustrator or AutoCAD or your favorite design software, such as, Inkscape or Lightburn or AutoCAD, whatever that software is, you can literally just drag it right into the Ruby software and it'll be operational. The formats that are supported are the most common formats in the design industry. SVG being a generalized vector format, AI, CDR, DXF, PDF, and EPS are all vector formats. What that means is that you can cut with those formats and laser edit and modify the image indefinitely. The JPEG, bitmap, and PNG formats are your pixelated formats that come from like a camera. These also work, but will only engrave with the laser machines. So understand that these formats are necessary. So if your graphic software can generate one of these formats, and I don't know any graphic software that doesn't support one or more of these, then your graphic software is compatible with Ruby. Ruby is going to allow you to make quick adjustments and modifications to that software, to those graphics after it's already been sent. So you're not going back and forth between your graphic software. As I said before, Ruby does not replace your graphic design software. All it does is just streamline the process so that you're not jumping back and forth every time you need to make a minor change, like change a name or spelling or some type of cut line. It gives you the ability to make those adjustments and modifications very quickly. All right, I think I was on mute. I apologize for that. Sitting here talking and nothing is happening. Sorry about that. And so let me go back a little bit because I'm not sure exactly where I cut out. The manage screen is basically an overview of all your design files. This is where all your progress is stored. Basically, any of the files that you drag in are stored permanently in the actual manage screen. The design screen kind of replaces your design software, as well as gives you the ability to modify existing designs. The prepare screen is basically job control, gives you the ability to lay out and prepare your jobs, position them, orient them, add materials database, as well as some design capabilities. And then your produce screen gives you the ability to actually put files in a queue. You can put them in order, and we're going to go through each one of these design screen flows now. This is an in-depth training, so it's going to actually show you every little bell and whistle, every little feature. I'm going to systematically go through and show you what each of the tools are, what they do, where to use them, and how they work. So next is that we're going to go through the manage screen here. The manage screen provides searchable storage for laser designs and jobs and the ability to import designs and ideas from other design software. There are 4 screens in Ruby, and the manage screen is identified by the 4 squares icon in the top center of the screen. Within the design screen, starting at the top, there is a question mark. Selecting this will show all keyboard shortcuts. This list will change based on what screen you are in. The small bell icon at the top of the screen will show all notifications or processes completed in Ruby. For example, this list is where the finished processing time of a completed file will be located. The machine icon is the connected laser to Ruby, showing the laser system serial number, selected lens, and type of laser being operated. The machine's registered name can be selected to change the password or log out of Ruby. The 3 bars on the top left of the screen next to the Trotec logo is the main menu. The main Designs tab at the top shows the designs that are currently loaded in the Manage screen. Selecting the Import button will allow compatible graphics and designs to be imported into the Manage screen. Compatible graphics can also be dragged into the Ruby Manage screen directly from a folder or another computer screen, one at a time or by selecting as many files as desired. Additionally, a zipped folder of compatible designs can also be dragged into the Ruby software and will automatically extract the files from the zipped folder and deposit each file into the design screen. Single files can be deleted by selecting the small trash can icon next to the file, or by selecting the checkbox next to multiple files and selecting the small trash can at the top right side of the list. Files can also be exported out of Ruby only to be used on other laser machines running Ruby. The design file list is searchable using the search bar at the top of the page. The plus button will take you to the design screen to create a graphic from scratch. The next tab at the top is Jobs. Jobs are files that have already been run through Ruby, have been positioned, and have the material parameter already selected, meaning these files are ready to be laser processed. If nothing needs to be changed in a job, such as location or the material type, that job can be dragged directly from this list to the operational laser machine shown on the right side of the managed screen. When this is done, the job will skip all other screens and be sent directly to the produce screen, bypassing all other steps. This is very useful for repeated production jobs. The jobs list is also searchable. Jobs can be deleted or exported like the design list. The next tab at the top is Profiles. Profiles are the next step towards automation in Ruby. Assign profiles with desired material and layout properties to automatically push files into your laser's queue. You can create profiles for recurring jobs by setting up the desired material parameters, position, scaling, rotation, and use of rotary if needed. Each detail for the laser job is predefined and saved as a profile. When files are imported or dragged into a profile, designs are automatically forwarded to the production queue. Here's an example of how profiles can drastically improve productivity once set up. Place the material or product into the laser, a powder-coated tumbler in this example. If the profile is set up correctly and the design files are created with the correct size and orientation, these designs can be dragged directly into the desired profile. The profile will automate all the steps in Ruby, allowing any file to be moved into the profile and instantly be ready for laser processing. Profiles are beneficial when each design has been customized in other softwares or created on a website by customers. Additional profiles can be set up by selecting the plus button. The last tab in the Manage screen is the Fonts tab. This tab allows the installation of custom fonts into Ruby when a non-compatible font is found. To add additional fonts, use the Import button or drag and drop. This will add any custom fonts into Ruby and enable full text editing when editing and designing in the Ruby software. Okay, that was the manage screen, and as you can see, it really does showcase a lot of the capabilities in Ruby, especially in the new features that allow for like the profiles. I really like the profiles. It gives me the ability to just drag that file in. If you have a bunch of files that are all generated in one specific way, but yet they're custom individually, you can literally just drag them in. I showcased the rotary there, but that would work with anything. If you do print and cut, or if you just have a flat sheet and you're just constantly dragging it in, everything's the same. You can basically bypass every conceivable step. It's all ready to go for you. The next screen is the design screen. This one's a little more intense. It's going to basically go through individual steps that showcase how to use the design screen. The design screen allows you to create designs from scratch or edit and modify existing designs or laser jobs. The design screen is identified with the letter T next to a pencil icon at the top of the screen and can be navigated by selecting that icon or by choosing any of the designs in the manage screen shown here. Along the top of the screen is the main toolbar. The first icon is the New Design button. Selecting this will start a new blank design page. Next is the Import button, which will allow you to import and open designs directly into the design screen. These files will show on the list of designs on the left side of the screen. Selecting any of these design files will open that design. These design files can also be deleted by clicking the small trash can next to the file. The designs list is a searchable list using the top search bar. Any active file can be saved with the Save button. When changes are made, it will automatically prompt you to save if this is not selected when moving to another design. If changes are made and you want the design saved as another name, the Save as New button can be used. Rubber stamp mode converts a design into a mirrored and inverted rubber stamp file. When this button is selected, the chosen design is converted and saved as a new separate file in the design list, leaving the original file unchanged. The selection tool is used to select objects on the screen. Use this tool to choose highlighted components by moving the selection tool over the designs. The line tool will draw a line. The circle tool will draw a circle or oval. The rectangle tool will draw a square or rectangle. The polygon tool will draw a polygon, triangle, or star. The import image to design will import an image into this design. The text tool allows text to be added to the design. The color list on the right side of the page can be used to change the color of any selected object or fix colors that may not be correct. The text toolbar that shows when text is typed allows for standard text, font, size, width, and weight adjustments. The undo and redo button allows for undo and redo of a project's progress. The Fit to Page button will adjust the page to the design, and the drop-down menu on the Fit to Page will allow for adjustable margins. The zoom tools allow for zooming in and out of the project by using the buttons, computer mouse wheel, or by using the zoom selection and drawing a box around the location that needs to be zoomed into. To reset the zoom, select the zoom percentage, and this will automatically reset the zoom to the page. When multiple objects need to be joined or welded together, like this circle and square, select the objects that need to be welded together, then select the union tool. The next tool is the intersection tool. This tool can be used in a couple of different ways. First, select the object to intersect, then select the letter C on your computer's keyboard, and that will turn that selection into a dashed line. Then select both objects and select the intersection tool. This will clip out the selection of that drawing. This same tool can also be used to clip a photograph. Open a photograph and then draw the object to which you want to clip the photo. In this example, a circle. For this to work, select the circle, then select the letter C on your computer's keyboard. That will turn the object selected to a dashed line. Then select both objects, in this case the circle and the photograph, and then select the intersection tool. This will clip out the photo into that shape. The next tool is the difference tool, which works the same way as the intersection tool, by selecting the object, then selecting the letter C on your computer's keyboard. And that will turn that selection into a dashed line. Then select both objects and select the difference tool button. This will clip out the selection of that drawing. The final tool in the same group is the exclusion tool. This works the same way as the previous two, but is only helpful on filled objects. I will fill the objects first, then selecting the object to intersect, selecting the letter C on the keyboard again, and that will again turn that selection to a dashed line. Then select both objects and select the exclusion tool. This will clip out the center selection of that drawing. It is also possible to trace a graphic in Ruby from a solid color bitmap, JPEG, or PNG non-vector or pixelated file formats. First, open and select the solid color image. Then select the Trace Image tool. Adjust the tools as needed, depending on the quality. Then select Trace. This will produce a traced outline of the non-vector image, converting it into a vector image that can be laser cut. The original picture can then be deleted, and the traced image can be used as needed. When multiple cuts are needed in a design, it can be time-consuming to move, adjust, and rotate components in a file to fit onto a sheet of material. This is where the handy nesting tool is used. First, select everything that needs to be nested, then select the Nest Shapes tool. This will automatically arrange, rotate, and position the cut files together, efficiently saving time and material costs. Please note that this tool may take a few minutes to complete, depending on the complexity of the design. Text, images, and other design elements can be aligned and distributed using the Align and Distribute tool. When selecting separate design components, this tool enables centering, alignment, and even line spacing when needed. Elements can also be positioned precisely on the plate. For positioning graphics together, use the Snapping tool. With this tool, objects will automatically snap to the edges or the center of an object, or the design page when used. Center snapping will show as dashed lines on the screen at each snap location. When engraving a design element like this star using thick line weights, the outline scaling tool may be necessary. This will allow the design element to maintain the same look as it is scaled up and down. Without this tool, the design's line will not change, producing a thick line when scaled down. The grid button will turn on the grid as needed. This tool defaults on but can be turned off with this button. If your laser system is equipped with a Vision Design and Position camera, or VDP, this camera can be turned on and off here. If the camera location needs to be adjusted, the Camera Adjust Image tool will allow the camera video to be moved to fit the design. On the right side of the screen is the design name that can be changed as needed. The size of the page can be manually entered here. Searchable tags can also be added if required, such as material thickness and notes. Selected design element dimension size can be adjusted here. This dimension can be locked and unlocked to maintain the aspect ratio. The 9 squares for that location can be selected to identify the design's location point on the screen. Mirroring tools for mirroring horizontal or vertical are located here. Here is the adjustment for a rotation factor for rotating design elements. When a non-vector photo is selected, the invert button will show, allowing images to be inverted when needed. When a vector line or element is selected, this tool allows a closed outline to be filled or outlined with this tool. Line thickness on a vector line can be adjusted here. Layers are all the design elements in the drawing. They can be selected in that layer and deleted as needed. All colors can be chosen independently of other colors, so that can be changed using the color palette. When design elements, such as text and photos, are selected, a small pencil icon will show in the upper right-hand corner. Selecting the icon will allow these elements to be changed, such as editing the text or font, or by adjusting the tone curve of this photograph to improve the engraving details onto some materials. The question mark button at the top of the page will identify the keyboard shortcuts on this page. And finally, when the job is ready to be laser processed, the blue Create button can be pushed to move that job to the Prepare screen. All right, that was the design screen. So lots of fun new stuff there. And if for those of you that may not have known, some of the new features are definitely showcasing there as well, such as the trace capabilities and the nesting capabilities. These are all additions that have been added within the last year or so. New features constantly coming about, and it just makes Ruby more and more exciting and more capable. The next screen is the most popular, but definitely the one that is the used probably the most, and that is the Ruby Prepare screen. So the next one I'm going to go through here is the Ruby Prepare screen. The Prepare screen offers a print preview with sizing, layout tools, and a built-in materials database, making preparing your laser jobs for production very easy. The Prepare screen is identified with the target icon at the top and can be navigated by selecting that icon at the top center of the screen or by choosing the Create Job button from the design screen. Once the file is in the Prepare screen, it can be arranged onto the material using the overhead camera or red dot pointer for exact positioning. On the left side of the Prepare screen are the two primary tabs, the Designs tab and the Jobs tab. These two tabs contain all the content that is stored in Ruby. The Jobs tab files are different from the Designs because they have already been set up with the material and are ready to be laser processed if they do not need to be relocated or changed. For example, suppose I open up this tiger plaque job. In this case, it has already been set up with the bamboo wood parameter, and the time shown next to the job indicates how long the job took to laser process, suggesting that it has already been run before. A job in the jobs list cannot be combined with another job. Jobs can be deleted from this list by selecting the tiny trash can next to each job, and then confirming this deletion if desired. The jobs list is completely searchable with the search bar at the top, allowing for quick access. The Designs list differs from the Jobs list because these are the files that have not been yet set to the laser. Because of this, any file from the Designs list can be imported into the job file by selecting the arrow on the left side of the desired design. The Designs list is completely searchable, with the search bar at the top, allowing for quick access. The main toolbar along the top of the screen contains all the tools needed for the Prepare screen. Starting with the New Job blank page icon on the left side of the toolbar will create a new page, asking if the existing job needs to be saved. The next tool is the Direct Import button. Pressing this will allow you to import files from other locations on the computer, opening a computer folder so that files can be selected. Once opened, these files will be placed into the design list, and they can be chosen to bring them into the design screen. Additionally, files can be dragged into this screen from another computer monitor or folder. And these files will automatically show up in the Prepare screen, while also storing the new imported design in the Designs tab. Any file can be manually saved in the Jobs list by selecting the Save icon. If a changed version of this design is needed, and you do not want to affect the original job, the Save as New Job button can be chosen, and Ruby will assign the word New next to that job and save it as a new job. The clock icon on the toolbar calculates the job time. The time given will change based on what material parameters are used. Once pressed, the time will briefly show on the bottom right side of the screen, and this time will stay paired with this job showing on the Produce screen when the laser is ready for processing. The Select Object tool or cursor is used to select, move, rotate, scale, and size jobs and designs in the Prepare screen. In addition, when an object is selected, the small pencil icon can be chosen. This will open up the graphic into the design page, allowing for editing to be performed as needed. In this example, I will remove the logo from this design and then select Update Job to bring that design back to the Prepare screen. In addition to the pencil icon, there is a small icon with 4 small squares. When selected with the Selection tool, it will open up the Array feature. This feature will provide the tools to array a single design into rows of that same design. Moving the mouse over the grid will automatically place that selected design into rows, or the exact number of rows and lines can be placed here. The rows can also have the spacing adjusted as needed here. They can then be reset, updated, or canceled. If updated, the changes will take effect. This array will show as a single design. To edit the array, select the same array icon to make any changes. Next are the drawing tools. The line tool to draw lines, the circle tool to draw circles and ovals, and the square tool to draw squares and rectangles directly onto the prepare screen. Next to the drawing tools is the undo and redo buttons for undoing and redoing steps in the prepare screen. The zoom tool allows for zooming in and out of the project by using the buttons, computer mouse wheel, or by using the zoom selection and drawing a box around the location that needs to be zoomed into. To reset the zoom, select the zoom percentage, and this will automatically reset the zoom to the page. Holding the spacebar down and dragging the screen with the selection tool will pan the page. Text, images, and other elements can be aligned and distributed using the Align and Distribute tool. When selecting separate design components, this tool enables centering, alignment, and even line spacing when needed. Elements can also be positioned precisely on the plate. Another method for positioning graphics together is using the snapping tool. With this tool, objects will automatically snap to the edges or the center of objects, or even the design page when used. Snapping will show as a dashed line on the screen at each snap location. Turning this tool off will stop the object from snapping. For non-run-on Ruby laser machines that are directly connected via USB to the computer, the lock laser head tool may be necessary. When this tool is turned off, the cursor on the screen showcasing where the laser head is located can be dragged on the screen in Ruby, and that will directly move the laser head that is connected to the computer to relocate that laser head. For a run-on Ruby laser machine, if this cursor is moved, it will only produce an error, as this is a safety issue, because a run-on Ruby computer can be anywhere in a local network. When this tool is turned on, it will not allow you to move the head by dragging the cursor when locked. The grid button will turn on the grid as needed. This tool defaults on but can be turned off with this button. If your laser system is equipped with a Vision Design and Position camera, or VDP, this camera can be turned on and off here. The camera view can be updated with this circle arrow icon. And the camera image can also be copied to the clipboard with this tool. Once copied, it is possible to open any graphic design software, and that copied image can then be pasted into the graphic in that software, so that designs can be drawn to scale onto the material, simulating what's inside your laser in your chosen design software. Please note that the page size of the graphic software needs to match the laser system's field for this to work. And in some cases, the pasted image will need to be scaled up to fit the page. This next tool is used to turn on the print and cut camera. When activated and the print and cut camera is installed on a compatible laser machine, combined with the correct file, this tool will activate the camera when processing the file. The following tool will activate the rotary. Once opened, the product diameter can be measured and placed into this field. When a file is selected, the 3D preview box will show an active simulation of that design on the entered diameter. This view can also be enlarged, and the mouse can be used to rotate and pan it for review. If the design is moved or adjusted on the main page, it will show up in real time in the 3D simulation. To turn off the 3D simulation, select the 3D button next to the rotary tool. Next is the rubber stamp tool. First, open a file generated in the design screen using the rubber stamp mode. The design screen is used to convert a design into a mirrored and inverted rubber stamp file. Once the file is opened into the prepare screen, select the rubber stamp tool here. When this tool is activated with a rubber stamp file, the image and additional tools on the right side of the screen will show up. These other tools will allow a rubber shoulder angle to be selected: flat, medium, and steep. If a rubber stamp is going to be cut out, links can also be turned on and off here. Links are small tabs that are applied to the cut that will hold the rubber stamp in place, so many stamps can be cut and removed at once, cleaned, and then broke away from the main sheet after cleaning. The small question mark at the top of the page will show all the keyboard shortcuts for the prepare screen. The small bell at the top of the screen will show all notifications. For the following example, I will draw a square, then select Ctrl+C and Ctrl+V to copy and paste that square. Here is an example when cut. The laser will cut out both squares, cutting the overlapping line twice. The following tool will allow you to skip this overlapping line, allowing you to save time and materials by overlapping designs like this. This tool does not default on, requiring you to select it for any job you need it for. I will now draw a circle and turn on snapping, and center this circle to one of these squares. If I want to guarantee that this inner circle will laser cut first, this tool will do just that. The Inner Geometry First tool will cut from the inside out when on. This tool does default on, but can be turned on and off here. Here's where the job name and tags are located. Tags are located for searching and notes. And a descriptive job name will also be necessary to search for it later. This area on the right-hand side is used to adjust the size of the graphic. The aspect ratio can be locked and unlocked here. Location and the location anchor points are used for a specific area as needed. When the upper left anchor point is selected and a location is added, that anchor point will move to that location on the screen. If that anchor point is changed, the new anchor point will move to that new location. The selected object can also be rotated manually by selecting the circle arrow at the top center of the graphic, or by manually typing the rotation angle into this field. The mirror horizontal and vertical tools are located here for mirroring a graphic. This tool is commonly used to reverse engrave an image into clear glass or acrylic. The reset button will reset the rotation. The searchable materials database is located here. This list includes recently used for quick access and favorite should they be identified. Materials can be searched for here and then selected in this refined list. After choosing a material, the parameters will show up by color. The color will have an arrow next to it so that all the parameters can be seen and adjusted. The adjustable settings include the power, speed, DPI, laser source, air assist, Z offset, number of laser passes, power correction, engraving direction, engraving mode, laser frequency, high quality mode, relief mode, dithering mode, and finally engrave covered mode. The color square can also be selected to showcase and change the color mode. For example, if the print and cut mode is turned on, this color can be assigned as the print and cut color. The cut setting shown in red here will have the material thickness and the material selected, including power, speed, frequency, laser source, air assist, Z offset, number of passes, power correction, and path planning. The Materials Detail button can be selected to see all these parameters laid out in a cleaner, more organized view and allow you to adjust these settings when needed. After opening this screen, selecting the Advanced drop-down menu will show all the same settings. And the three dots on the right side of each color can be used to copy from or delete the settings on this color. Settings can be applied to the color. For example, if I wanted to speed up the engraving on the black color by converting 50 to 60%, an error will show that the setting has been modified. And selecting the Reset button will revert it back to the original setting. Should you like to keep that setting, select the Store button. Then save this new setting as a completely new setting, or overwrite the existing setting, effectively changing this setting by then selecting Save. As you can see, the setting has now been permanently saved. At the bottom of the page are the exact coordinates of where the laser head and the Z-axis is located at the time, if this information is needed. Finally, when the laser is ready for processing, send that file to the produce screen by selecting the Q button. Additionally, if no files are currently in the queue, you can also select Push to Laser, which will take you to the fourth and final produce screen for laser operation. Okay, that was the prepare screen. As you can see, that was the large one. Most of the work I find is being done in that screen, especially if you already have the file designed in your CorelDRAW. You can literally just drag it right in there, make your adjustments, modifications, adjust your materials databases. There has been some recent changes to the material parameters, as you see from the previous versions. It's a lot more refined, a little easier to use, in my opinion. The materials database itself is still there, but you have to go to the main menu in order to access the materials database, which we're going to cover here in a few minutes. So the next page here is going to be the produce screen. The produce screen is the final screen. This is basically for controlling and running your laser system itself. So we're going to go through the produce screen here. The produce screen features a queue of previously ran or ready to run laser jobs ready for laser processing. The produce screen is identified with the laser machine icon at the top of the screen and can be navigated by selecting that icon or choosing the Push to Laser button with a single design. When the job is ready for processing in the Prepare screen, that job can be sent to the produce screen by selecting the Q or the Push to Laser buttons, then by selecting the icon at the top of the page that looks like a laser machine. When the produce screen is opened, it will show all jobs sent to the queue. These jobs will also show in the center of the Run on Ruby touchscreen. If you do not have a touchscreen, they will show on the left side of the screen on a computer. These jobs can be selected and moved to change the order. Whatever job is assigned will be the job laser processed. The small X in the corner of each job allows for that job to be deleted if needed. The center of the screen are the details of the job name, selected material and thickness, and the process parameters. There is also a switch to Remove Completed Job from Queue. If left on, the jobs will automatically be deleted when finished. If turned off, the jobs will remain so they can be rerun as often as needed. And these jobs will remain in this queue even if the laser machine and computer are turned off. The play and stop buttons are there so that the laser can be started on the computer. These two buttons will only work on a non-Run on Ruby laser machine. The Run on Ruby machine, or lasers with a touchscreen control computer, can only be started on the laser's control panel for safety reasons, as they can be run far from the computer that sends the jobs anywhere on a local network. The progress bar and time shown here are only an estimated processing time. And this time will only show if the Calculate Job Time button is selected in the Prepare screen prior to sending the job. The large clock will start once the job is started on the laser and show the exact processing time during the active laser process. An image of the selected job is shown on the upper right-hand side of the screen, with an optional full-frame view to confirm all job details before laser processing. Once satisfied with that view, the Escape button can be selected to return to the previous view. Finally, the small trash can at the bottom left of the screen can be selected to delete every file in the queue. To keep from accidentally pressing this, it will prompt a warning confirming the deletion of the queue. Once verified, all processed files will be removed if desired. I will now run through the process of sending the file to the queue, starting that file and processing it with the laser to show this screen in action. The laser machine is already on, and the material has been loaded and focused on. I will start by placing the design file over the material with a material parameter already selected. Then select the Calculate Job Time button, and then push the file to the laser. Or select the Q button and go into the Produce screen. The file shows up simultaneously on the laser machine's display and a computer screen. Select the file, then press Start on the laser. The laser machine will start the job, showing the estimated time at the bottom of the screen. And the progress bar will show the job's progress. The large clock will count in real time as the laser job processes the material. The time will always be about 4 seconds longer than the simulation, as the clock accounts for the laser head movement to and from the home location. Once finished, because the button to remove the completed job from queue is turned on, the job will delete from the queue when finished, showing a blank screen if there's no other files in the queue. Select the small bell at the top of the screen to see a time log of past laser jobs if needed. Once complete, remove from the laser for the finished results. The Produce screen features That was the Produce screen and the final process. The last one I'm going to cover here today is the Ruby drop-down menu. These are the different menu items for modifying, making changes, and stuff like that. And so we're going to cover that, and then we're going to go ahead and cover some other stuff that are typically asked. The main drop-down menu located on the left side of the screen will provide access to some capabilities that are not located anywhere else within Ruby. It is identified by the 3 bars in the upper left-hand corner next to the Trotec logo. Select the 3 bars and you will see the menu here. Within the menu, the first tab is the Manage screen. Selecting this will take you into the Manage screen. Next is the Design screen. Selecting it from the main menu will take you directly to the Design screen. Next is the Prepare screen. Again, selecting it from the main menu will take you directly to the Prepare screen. Finally, it's the Produce screen. Again, a direct link to the Produce screen through the main menu. The Materials database is also located in the main menu. Within the Materials database is all the materials located within Ruby. This database is directly searchable. You can select the 3 little dots here to add a new file, import from a cloud, import from a file, export a selection, and delete the selected material. To add additional colors and operations to a material, select the Add Effects material. This will allow you to add your own effects as well as additional colors to an existing material parameter or a brand new custom parameter. If you would like that material to be a favorite to be used more often, you can select the Favorite button. Tags can also be added, which are searchable. And the drop-down menu under Advanced is so that material settings can be modified, changed, or edited. Next in the menu is the Profiles. Profiles are a quick connect so that you can directly drag files into this profile, having all the parameters preset, optimizing productivity. User Management is the next on the list. User Management is how to set up additional users to Ruby. You can select Add Users, put in an email address and a username, and that user will be emailed information on how to access Ruby within a local network. Alternately, you can also select Remote Network and then have access to these same links so that anyone with these links can access Ruby within that network. The Settings menu is the main menu for making modifications to Ruby, such as the units, metric and imperial, the languages, adjusting the PDF import capabilities, the PDF import mode. Down below that is the user device settings. These are location points, adjusting and turning on the lid camera, home positions, gas assist, exhaust capabilities, retreat position, and here is where the lenses will be changed, camera calibrations, camera calibration jobs, as well as factory calibration numbers that may be needed by the service department when calling for service questions. Anytime a menu is changed, the Save button in the upper right-hand corner needs to be selected. You can select the Info button for all information for the machine connected to Ruby. Going back into the Settings menu, we will now select the Service button. The Service button will allow updates to your firmware of your laser machine, as well as other actions shown here, like saving the service device settings into the cloud and unlinking the device. Back into the settings again, and now we're going to go into the features. Features are experimental features such as nesting, import profiles, and custom fonts. These can be selected and deselected and saved as needed. Next is the Ideas menu. If you have any questions, concerns, or ideas that you would like to add, please fill out all pertinent information and share your feedback so that the Ruby software team can make those adjustments based on popular demand. Next is the Ruby Help button. The Ruby Help button will take you to the rubyhelp.com website. This help screen will have access and information on all the features and capabilities within Ruby. The service file, when selected, will automatically download a service file from your laser machine. This may be necessary or requested from your service team when an issue or concern has been found. Once that file is downloaded, it can then be emailed to our service team. Next is the Manuals menu. This will take you to a direct link within the website to download the manual based on the model of machine that you are operating. That was the final menu. And so now I'm going to go through some different tips and tricks, as well as some Ruby frequently asked questions. These are some efficiency tips that I get a lot of questions on how to actually create some of these different techniques, problems that people actually run across with commonly. A common mistake when opening a file in Ruby is leaving the excess margin around your design file and creating a job. This will create extra white space around it. Instead, go back to the Design tab and fill the image to the design. You can assign a margin at this location to your specific dimension and adjust it as needed. I prefer adding a 0 margin so the cut lines are actually going to be right on the 0 margin of the graphic. When you do this and update the job, the individual file is the size of the file itself in the main prepare screen. What this allows for you to do when a material is selected that's going to be cut is increase the efficiency. You can select the array function and then overlap that file so that individual cut lines in this case will overlap. Once the array feature has been determined to get the most efficiency out of the material, select Update, then select Skip Overlapping Cut Lines, Straight Cut Only in this example, and then push the file to the queue. This will give you by far the most efficiency when cutting the material, saving on time and material costs. A common mistake when opening a file in Ruby is leaving the excess margin around your design file and to install a custom parameter, first find that parameter at a location. In this example, a video or a website. Download the parameter, locate it on your computer, go into Ruby, select the drop-down menu, select Materials, select the 3 little dots, and import from file. Find the location where the files are located on your computer, open that folder, select the material parameter, select Open, and the new parameter will then show on your materials list. To install a custom Sometimes when you open files into Ruby, they may not be correct when it comes to certain colors. So when you create a job and look at them in the actual prepare screen, some of those colors will not show up. In this case, go back to the design screen and check the colors. If there's an asterisk next to the color, this is an identifier that the color is not correct. You can then select the box next to each color and identify the correct color for the cut path or the engraved setting. If it is a grayscale and you want it to be black and white, you can also convert it to a black and white at this point. So in this example, the red, blue, and black were all incorrect. Now they are correct. 100% black, a vector blue line, and a red cut path. Okay, that's it on the actual overall training. The advanced, sometimes you're going to have actual questions, and I didn't get too much into some of the advanced features, such as print and cut and rotary and stuff like that. I do have some advanced video links that I've already done this information on. So here is a few different links. First one is the print and cut. If you want to go through and kind of walk through the process of how to create the design file, as well as matching it to the print file, sending it to your printer, as well as to your laser machine. And then finally, how to set it up so that the file is identified in Ruby, all the different little buttons and modes that you have to turn on with Ruby in order to do a print and cut. You can watch this video. We're not going to go through some of those real in-depth projects as much on this course because this is just a basic overview of Ruby. But if you do want to go ahead and move towards doing print and cut, you can scan the QR code if you haven't already watched it, and it'll go through the entire process of designing it, printing it, sending it from, and then taking it from the printer, putting it on the laser, separating that out and running the cut file, how to set it up in Ruby exactly step by step so that you get an exact print and cut type design file. The next one, I didn't go too much into depth onto the previous, it was the rotary. I have another course here that's, again, designed specifically with Ruby. On exactly how to install the rotary all the way through the Ruby operation and how to go and actually process a diameter, make sure the diameter is set right, and a lot of different details on the rotary itself. There's some questions on this one. And so this video is going to basically show you basic operation, installation, and training. If you want to go a step further, I've just recently done one that is going to really go through and showcase the rotary, including running on both sides of a mugged handle, compensating for that mug handle, accounting for the rotation factor. Sometimes Ruby, for example, likes to rotate the rotary halfway through the engraving because it's partway in its rotation factor. This video will showcase how to avoid that. It's also going to show you how to engrave equally on both sides, accounting for a mug handle so that that mug handle doesn't actually hit the focus head as it's rotating. The direction of engraving, all the details of the rotary to really get into down a rabbit hole specifically for this application. Because it's several minutes long and to do just that, these are not components that are on the actual Ruby training, but I already have a video specifically for those types of common questions and concerns that are going to go through and walk you through step by step on just how to do that. If you ever have any questions on these videos, feel free to go ahead and post any questions on it. We keep a close eye on those questions, and we will definitely answer those questions should you have it after you've watched those videos. As I said before, there is a lot of Ruby help and feedback. The rubyhelp.com is definitely there for you. If you do have that quick question, what does this tool do? Maybe a little tool that I didn't really describe or go into detail down the rabbit hole of exactly what it does. You can go into Ruby Help, find that tool, and it's going to give you a description of what that tool does, why you might need it, and more specifics on that. These are definitely different information that's here for you. And if you do have the Ruby idea is something that is a very, very useful tool. So go in and actually click it. If you do have questions and you really want to help our software team expand, if you've got that tip, that trick, that little thing that you really wish Ruby had, go ahead and post it in here. Our software team watches this constantly. And so those questions, and then the more of you folks out there that decide you want to go ahead and post these ideas, the more chance that object will, or that idea will be posted on future versions of the Ruby. It may take some time, but if you don't post it on here, no one will ever know about it. And the only one that may be frustrated by it may be you. So please, please, please make sure you go ahead and share your feedback, no matter what it is, within the Ruby software. If you missed the original download, here it is again, ruby.troteclaser.com. You can download it if you haven't already. Go ahead and scan this QR code. It'll take you to the link, and then you can go ahead and get access with Ruby. Again, it does work simultaneously with Job Control. So you can run it with Job Control and Ruby at the same time on those systems that are non-run on Ruby machines. So go ahead and do that if you're not currently already doing it, or you're just looking to maybe expand to the Ruby. And that is it. That is the entire course for today. We're going to go ahead and now go live and ask any of your questions. Corey, my wonderful coordinator here, is going to go ahead and start posting these questions on our YouTube channel for me to read here, and we can determine and hopefully help you out with any of these questions. I also have Ruby up here so I can access it if I need to show you anything. So let's go ahead and go ahead and ask some of these additional questions here. Will Ruby work with my Rayjet laser? Yes, eventually. Right now, as I said early on, Ruby will not work currently with the Rayjet yet. It is scheduled for this year. As for when, they haven't given me an exact date. It's just stating on our website that Ruby for Rayjet laser system is scheduled for release this year. The new Speedy 400, all the machines, we could not drag the laser head software in the software, but now we see direct connection warning. And that's something I did cover. That basically, when you have a run-on Ruby laser machine, it can be remote, and we do not know where that laser system is located within your network. So you could have your laser machine downstairs and your computer upstairs. And for safety reasons, dragging your laser head from your computer screen and allowing it to move is a safety reason. So the non-run-on Ruby machines, as I stated, can do that, but the direct run-on Ruby machines, being we don't know where it's located, we cannot allow that to happen for safety reasons. If somebody's arm is inside that machine and you remotely move that arm, there's no way to know whether or not that is going to be the case. And so that's why we won't allow that process to happen. How can we change the test pulse in Ruby? Job control allowed us to go backtrack and backtrack of our laser and power to new machines. Yeah, that is something that Ruby does not have access to. There is no test pulse that I know of. That would be more of a question for our service department. I've never really had a need for that. So I guess there may be a possibility to be in there, but I honestly do not know exactly at this point. So that's a question for our service department. I don't think Ruby allows for that test pulse to be actually run. So in that case, you may need to go back to job control or contact our service department. They can definitely help you out there. Can this be installed on a Windows 11 computer? Yes, Windows 11 is compatible with Ruby now. And so if you do need to go ahead and update to your Windows 11, it's been out long enough and it is supported. Remember, Windows, the version of the operating system is not something that is an issue at all, because Ruby is a network based. And so you actually access it through Chrome or Microsoft Edge, basically your browser. And because of that, the operating system really doesn't matter. So it doesn't really matter what version you're running. But yes, that is something. Now, if you're running an old Windows or an old non-run-on Ruby machine that's connected directly, that was something that was important. And so it did take a while to get compatible with Windows 11. But no current new systems, that is not an issue. Go ahead and update. As I stated earlier, yes, the speed marker software is later on that list and will be coming out. I have heard as late 2024. What did you clean the wood off earlier when you made the box? I just used a damp cloth. Typically, when wood is pre-finished, it's very easy to clean after you laser process it. What I mean by pre-finishing is that laser or that wood has been clear coated with a polyurethane, lacquer, varnish, or some type of clear coating. In that case, just a simple damp cloth will remove the residue from the surface of that wood very easily. We got to do Speedy, and the old rotary attachments are still compatible when you run on Ruby machines. Unfortunately, no. If you have an old rotary and a new machine, they are no longer compatible. There is a difference because the electronics have been changed. Unfortunately, your best bet in that case would be to sell the old rotary to somebody who may still have the old model and then get a new rotary that is compatible with that new machine. So I apologize. That is something that had to be done in order to make it compatible with the communication back and forth to Ruby. Does Ruby have text to path yet, or the ability to type above and below a path? That is a great feature and something I highly recommend. The answer is no, we don't have it. But what I highly recommend is you put that in the feedback. I would prefer that myself. That is a great feature. And so if you wanted to wrap text around, say, a curvature or something like that, or fit text to path, no current plan that I have heard of to add it, but the more of you folks out there that post that in the question, you'll find things like that can be added very quickly. So who knows? But right now, nothing is planned, and no, it does not. In job control, you run multiple jobs with the same parameters at once. Is that possible with Ruby? Yes, Ruby, you can run well beyond job control. For example, Ruby, you can run all the same parameters as well as different DPIs. For example, not only can you run the same parameters, but within Ruby, say I want the color black to engrave at 500 DPI and the color green, I set it up to engrave at 1000 DPI. I could not do that in job control. So I can vary the DPI based on the color in Ruby. So not only can it do what job control did with the parameters at once, it can also do additional stuff and adjustable changes within those files. So yes, absolutely. Has anyone tried to import settings from job control to Ruby successfully? Yes, this works very well. You can actually find your parameter settings that were saved in job control. And as I showed you the link on how to import those files, job control files or settings, parameter settings, not necessarily the files. You can't import the files in, but you can import the parameters. So if you have a lot of old custom parameters that you set up in your job control, those parameter files can be imported into Ruby the same way I showed you on one of those last videos, just by going into the materials parameter, selecting the three little dots in the upper left-hand corner of Ruby, and then selecting add the files, and then select the folder wherever those job control file parameters are located. And then you can go ahead and import those files directly into Ruby so that they are accessible. Pending your laser machine is the same machine, there should be no difference, and all those same parameters will work. Anyone experience overlapping script text that has curved, misleading gaps at the letter connections? Happens quite often. Script text. I'm not quite following that. Curved and missing little gaps at letter connections. I'm not. You may need to elaborate on. Is this on the actual cutting process? For example, for when you're actually cutting it out, parts don't actually fall out, or are you talking in the design itself from Ruby? If you could repost and elaborate a little bit so I can maybe get an understanding what your question is. Is Ruby able to cut dashed lines? I know I have had some issues with that. Some dashed lines, when you send it to Ruby, would be seen by Ruby as a straight cut line. In my experience, it really depended on the type of dash line. Some work and some do not. Currently, I don't know if that error has been corrected. The last time I tried it, the dash line that I did used on the new version 2.6 did work fine. I haven't tried all versions of dash lines, but I do know the 2.6 did solve some of those issues, if not all. And currently, I haven't had any more issues, but I would go ahead and test it more. Certain lines that have the spacing was what I found. Certain spacings worked, certain spacings did not, and that was the difference. So a little more, make sure you've updated to the latest version and try it again. If not, go into the Ruby suggestions and put it in there. Make sure you post those questions to our software team that these features don't work. You can even include the file. So if you have the PDF or CorelDRAW file, go ahead and include it with that, and then they will try it out and make sure that future updates don't have these problems. Is there any plans for a framing feature? Oh, great feature, great idea though. Not that I know of. Software team hasn't mentioned anything for me on that type of thing. Again, that's a great one to go ahead and put in there. Make sure you go ahead and post it. Hey, add a framing feature, and give them as much details as you want, specifics, details. You can even mention, framing feature like I have in CorelDRAW showing this and this and this. Currently, that feature is not there, and there are no plans that I know of. And that's not saying that it's not happening, that I know of that is currently happening. Any tips for ensuring that the lines are the same height for an engraved rubber stamp? Ensuring that the lines are the same height for an engraved rubber stamp. I guess I'm not following you here. The individual heights. Can you elaborate a little bit? I'm not sure what you're mentioning here. The same height for a rubber stamp. Are you talking about the shoulders or the cut lines so that they're the same? I mean, you're not talking like snapping the cut lines to the same specific location. Snapping and the new align and distribute tool are handy for making sure they are the same heights. If I'm not following you, please elaborate. Is there any way to turn off the features of the edits in the files being imported? Because it often removes spaces between words and change text sizes. Yeah, that has to do with a lot of the font issues that I have found when there are certain changes on the importing. I have found importing can be tricky sometimes because the main issue that I have come across is there's literally millions of possible combinations of design can be created in your design software. And if it's different layers, if it's different transparencies and stuff like that and types of line segments, and they may not come in properly, or the type of font that they may not be compatible with Ruby. This is why they've added the font feature. So for example, if the font comes in incorrectly, a lot of times it's because it's substituting a font. And in that case, you want to make sure that font is done. If you do run into once in a while strange occurrences when importing a file, try a different format. Try the more generic formats to be sure. For example, the SVG or the PDF are going to be your most generic formats. If that don't solve it, sometimes go back to your design file, make sure you merge the layers and stuff like that. Rubies are definitely getting better. Earlier versions, we had a lot more problems, and every version I have used has gotten better and better. I had a list of like 10 different files that gave me problems like this. And the latest 2.6 version came out, it's down to 1 that still has a problem. So that problem is constantly being addressed. Again, that's another question that you can post on our YouTube or in the tips or for posting a comment if you have these type of concerns. Our software guys, it's a never-ending revolution of software design programs changing and then Ruby trying to keep up with it to maintain that compatibility. Again, convert into an SVG or PDF if you're not certain, or revert back to an earlier version of CorelDRAW or earlier version of Illustrator if that's the software you're using. A lot of times that'll resolve it as well because it's more of a compatibility issue than a format issue or an issue with the importing feature. And so that'll solve it in a lot of time. But again, report those type of issues so that our software team knows about them. Any plans to make the laser X, Y, and Z on the lower right-hand corner to prepare more visible when the camera mode is on? When zoomed over the honeycomb table, the settings are impossible to see. That's a great comment. I don't use those features, but yes, you are right. The X, Y, and Z coordinates that are identified in the lower right-hand corner, which I showed during the prepare screen, was indicated there. And they are kind of small and as well as kind of transparent almost. And you are right. That's not one I've ever been asked, but again, that's another question to post on it. No plans to do that. Not a lot of people use that. So unfortunately, that is kind of the way it is right now. Post that question definitely in the tips area and see if those guys can maybe move it to another area. I do agree it needs to be kind of like on the main screen, maybe up at the top so that it is a little more visual. Okay, on occasion, I've needed to stop running the job due to an issue. See the job icon on the produce screen Q, but many times the X for delay is not searchable. Or the X for the delete is not selectable. I'm sorry. Yes. When your system has been paused or stopped, you can't delete the file until you stop the file. And so the system is still basically in a hold pattern when you can't delete the file out of the queue. So in those cases, make sure you hit the stop button. And the one thing that I do, if you want to guarantee it stop, click and hold the stop button on your laser machine for like 5 to 10 seconds. This will force it to stop. And in that case, once it has stopped, you're going to usually hear a beep on your laser machine, and then you can go ahead and then go into your menu and then delete those jobs until that job has been held up, because in essence, it's seen if you stopped it or paused it or lifted the lid, the laser is seen as a paused job. And because it's paused, it's not going to allow you to delete it. So make sure you hit the stop button, hold it for 10 seconds if necessary until it beeps, and then you're going to have access to delete those jobs. As a job control manual, is there a way or ability to add sound audio notifications when the job is complete? No, that's a great idea though. I do know that the laser system beeps, but there is no custom like beep. I mean, right now the laser system does kind of beep when it's done, depending on what model and system that you have. There is no way to do that, but I can't see why that couldn't easily be added digitally so that it comes out your computer screens or speakers, for example. Right now, that is not a feature that has been added, but I do like the idea. And then, of course, if you can upload a sound, you could put your favorite song at the end, so it plays at the end of the job. So yeah, that is something that is possible. I can't see why it would be difficult to incorporate, but currently, no, that is not a feature. How do you make a home position marker in Ruby? And I apologize. That is, you are absolutely right there. I forgot to mention markers. Markers are an ideal feature. Let me actually go back to my screen here, and I'm going to show you that. So I'm going to open up. All right, so I'm back in Ruby here. This is a live version of Ruby right now. And so if I want to actually place a marker in the screen, so what I'm going to do is I'm going to actually move the head to where I want. And unfortunately, I can't do that because my laser machine is not on right now. But if you click the actual little question mark in the upper right-hand corner to add a marker, you're going to see here, it's the F8 key. So add a snap marker to the field. What a snap marker will do is it's going to literally, wherever your head is located, when you hit the F8 key, and it won't do that here when I hit the F8 key. Well, I did it. So put a marker right over the top of that. Now, I have found in some cases markers don't work. And do you know what I found causes that? It's the keyboard. Certain keyboards, the marker would not work. I don't know why. Would I plugged another keyboard into it? Maybe it's how that keyboard works. But the more generic simple keyboard work just fine. But on some more expensive high end, when I hit the F8 key, the markers will not work. What markers do is give you that positional air. And so you can snap items to it. And so if I wanted to take and actually snap a graphic to the marker, I can literally snap it to that marker. So the marker would be in the upper left-hand corner here, but it's going to give you that ability. And anywhere I move that head, I can hit F8 again. So if I'm targeting something with my red pointer on it, say I wanted to target the corners of this board, for example, and then shut the camera off, and then add different markers to where that's located with the red dot pointer, I can add a marker to each corner, draw a box there, and give me an exact representation of where that product is. Markers are very useful, and I apologize that I forgot to add them to the prepare screen training. There's so many little details I missed out on that one. So that was a great question. Okay, moving back here. What is the next question? If direct connect, is it possible to change the laser location and height from the Ruby on the computer in the prepare screen? Not only manually from the Trotec laser. You can. It doesn't really give you the ability in Ruby to change the location of your. You can drag it using the drag features to a location, but you can't really type it to a location like you could do in job control. Job control definitely did give you a little bit more controls over positioning your head and height over the area. You can put z-axes and you can drag it in the direct material, but that's it from the Ruby software. Our PC connection is to two lasers. Periodically throughout the day, Ruby loses its connection to our SPD300. Would that be a PC issue or a soft issue? That is a good question. So you're losing connectivity. So Ruby. Now, to give you an idea, if you're running multiple computers from the same login, when you select one, it's going to actually log you out of the other one, just so you know. if you're using it, and that may be what's causing it. And so if Ruby is logged in under the same user and two people try to use it at the same time, it will log you out while that system is being run, while the other computer is being run. And so that is going to be automatic. If you don't want that, set up another username, and so that each computer can actually run separately, and they can run independently of each other. And that way, when files are sent, only the master computer or the main computer or the run on a Ruby machine will show the individual files. And so that may be. So for example, if I have 6 computers and all 6 of my computers run all 5 of my laser machines because they're all run on Ruby. And so I can click any one, but since I use the same login, anytime I go to another computer, it's going to log me out of any other computer that may be logged into. Now, if I set up a different login for each one of the computers, I could effectively access any of those computers simultaneously at the same time. This is ideal for when you have multiple people, maybe a school, for example, each of the students can be logged into Ruby, designing, developing, and sending to the laser independently of each other. But they do need a separate login for that to work. In Ruby, is there any way to change the nudge distance? Unfortunately, no. Another great question, and one I do as an operator completely agree with. So nudge distance would be the when you push your mouse key or your cursor keys or the cursor on your laser machine to actually nudge it to a specific. There is no adjustment for that nudge distance, but that is a great point. Please post that on there. I post these questions all the time, but I'm one man. And the more people that post these types of questions on there, you're going to see these features and capabilities. Because sometimes, you know, I hate to say it, but our software guys aren't advanced users like we are. And so sometimes they don't come across these type of questions and concerns because they're not concerned with little things like that. And so make sure you post those questions. Don't think someone else is going to do it. They really do make a difference. On the ones that I have posted many times, and I've had other people post the same questions, usually within the next release, those problems have been resolved. And the nice thing with Ruby is it's released about every 3 months. About every 3 months or 1 quarter, 4 times a year, Ruby is updated. So these new features don't take long to be incorporated. Overlapping script text, rastering curved text, connected script cursive with the letters connect. I think this is a response to the previous one. There's missing gaps in the engraving. The letters have been like the letters have not been welded. I know what you're talking about. Okay, so for example, in this case where you have script text, that is interesting. I think this is an import error because if, for example, when you have script text, if you convert it to an outline, so you just see the outline of that text, you'll notice that like cursive fonts and stuff, literally when the lines are together, you will literally see an overlap of that case. And so this has to be an error that Ruby is doing it. So the only way I can think to resolve this right now, that is definitely a bug from what I can sense, is to convert it to a curves. So convert that text to curves so that it comes in properly. Because what's happening is Ruby is interpreting. The other possibility is trying a different format, but I think that it has something to do with how it's interpreting your font. Thirdly is make sure you install that font in Ruby, make sure it still works. But I do know what you're talking about. So when those overlap scripts are put together, little points are seen by Ruby. It's kind of like they've been combined together. So if you've ever taken a file like that and combined it in, say, CorelDRAW, it does the same thing. Those little lines will overlap, and all of a sudden they will turn white when they should have been filled because of the way that it combines. And I believe Ruby's probably doing something similar. So import the font, try that. If not, try sending it as a different format, like a PDF, JPEG, or not a JPEG, a PDF or an SVG format. And then thirdly, make sure that font is installed by dragging it into Ruby. Hopefully one of those will definitely resolve this issue. If not, reach out. Is there a way to have Ruby use at least the last laser setting instead of resulting to the default setting? We run 2 tumblers in a row. Have to reselect the tumbler settings for the second tumbler. Yes. Now, the order to which it's going to engrave is going to be identified by the order that it is sent. In the Ruby software, you can actually identify what order it's going to be run. You can also add a feature that does the overlapping. So if you have, say, two different colors that are overlapping, it's only going to engrave what's seen. But there's a feature in Ruby that's called overlap mode. Let me go back to my Ruby screen here, and I will show you what I mean. So in Ruby, under the parameter setting or the material setting, let's go into a file that actually has black and white on it. There's a mode at the bottom called engraved covered layers. So for example, if I have multiple colors overlapping itself, so I have a blue line or a blue fill and a black fill, and I want to engrave both of those colors on the same file, the laser will engrave them in order of color, first of all. So if you have multiple colors or different colors, we can do them by changing the order here. So if I wanted to make sure, now it's always going to do the engraving before it does the cutting, but say I add an effect and I just add a, if I add an engrave effect here, and then I add an additional color. So maybe I want to do that. This color will engrave first because it's at the top of the list. If I want black to engrave first, I can select the black and move it to the top. But if I wanted both of these colors to engrave, you know, and I can put in my power settings here, and then I can store and then save. Now both of those colors will engrave. But if I wanted to engrave them overlapped and engrave them at the same time, even though they may be overlapped, and so the file, for example, is two different colors on top of itself. So if I have two different colors, I have a black file. And so say, for example, I wanted to engrave this file, the blue one here, behind the black one. So if I were to create a job and if I were to send this to the laser right now, if I have the overlap button turned on, which the engrave covered here, it'll engrave both of those files and compensating for the and give me the parameters and engrave both parameters that are assigned. Right now, I don't have an assigned file for this, but it will allow you to do that. And so if you do have multiple colors and you want to engrave them both at the same time, or if you want to change the direction or the amount of colors within the file, well, that's why it's not showing up because I have the wrong selected file selected. There, now both files will show up. I don't know what file I changed, but anyway, you have a couple different ways. You can adjust which color engraves first. You can also engrave multiple overlapping. So it'll engrave the settings for the black, and then it'll engrave the settings for the blue, or even if it's overlapping. So for example, if I have a direct overlap and I want to engrave at high power with the color black, but then I want a cleanup pass with the color green, it'll engrave the exact file twice, but with two different power settings. All right. Next question. Rubber stamp height. Oh, this is the answer to that other question. When you look at the engraving, there's different depths for the leftover material. Tallest points and the shortest point. There's a texture that we don't want. Okay. So the background texture. Yeah, I don't think there's any way to actually control that. Unfortunately, not that I know of. The Ruby rubber stamp features are pretty limited, you know, in the fact that they don't give you a lot more control. They only allow us to do the tabs as well as the shoulders. We don't really have any ability to make adjustments within those areas. That is where the job control software still has a few more features that Ruby does not, but it is coming. I have been affirmed that the Ruby updates will have some of these new features coming up, but currently, unfortunately, there's no way to correct that. Is there a way to export a file from Ruby? Yeah, this is a common question. We use the CNC router. Sometimes we want to pull a file out of Ruby to play with the multiple files. Yes, that is a question that I get all the time. And unfortunately, the answer is kind of, but no. You can export a file out of Ruby, as I said there when we covered it early on in the design screen, but the problem is that file can only be exported so that you can import it into another Ruby software. It will not allow you to export your modifications or changes, say, as a PDF. And that PDF could be brought back into your design software that you use for your CNC router. Unfortunately, that is not. And so if you design it directly in Ruby, there is no way to get that file out. Definitely another question I would post on our forums and for the questions, because I would also like the ability. Sometimes I'll design something from scratch, but then I want to add a capability or bring it into a file like that, or add something that can't be done in Ruby to that file. But unfortunately, you can't export it out for that reason at this point. Occasionally, when using the rotary, I see some stretching or pinching on the engraving, even if I measured and entered it correctly. Am I doing something wrong? Most likely, you're not doing anything wrong. There's two things that's going to cause this. One, the diameter is not set. Two, there's a taper on your graph or on your actual tumbler, for example, and the diameter is there's only one diameter put in. So if you put it in at one diameter and the engraving tends to go down like an angled tumbler, or maybe it's something like a martini glass, that diameter is going to change drastically. And when it changes, it's going to skew, stretch, modify, make your graphic look. For example, if you were to try to do a circle and it's not a perfect cylinder and you engrave that circle, it always looks a little distorted. There's no way to compensate for that because the diameter is right, it's rotating it correctly, but the problem is the diameter varies. And so when the diameter varies, that circle looks slightly elliptical. There's a way to there's a workaround for that. For example, if it is a circle, I would run a test, then I would measure the circle, and then my original design file, I would actually take that measurement from the engraving and then adjust the opposite in my drawing so that when it does do it, it compensates for that curvature. It's not even the curvature, it's the angle that it's compensating for it. The only other thing that would cause this is if your image is slipping in the rotary. So it's not in there tight. And so as it's rotating, it's slipping a little bit. So make sure it's completely seated in your rotary so that don't happen. Is there any way to direct connect to a run-on Ruby machine? Unfortunately, yes, there is, kind of, sort of. You can plug a Ethernet cable directly into it, and it kind of direct connects it, means it bypasses the whole internet, but it does severely limit some of your capabilities, your updates and stuff like that. So we don't recommend it. And it's still not going to work, say, like the USB. So you're not going to have that communication directly. So like be able to move the head back and forth. So it's, in the rare cases where you don't have network capabilities and there's, a scenario where there's no other choice, it does severely limit you in its capabilities, and I don't recommend it, and it doesn't really benefit you. So the answer is kind of yes, but mostly no. Is there a fast way to speed up the materials library and the way job control does? Those setting up a test speed matrix to correct set. I know exactly what you're saying. So what he's saying here is, in job control, you literally had all 16 colors laid out. And in Ruby, in order to set up all 16 colors, you have to literally set up a matrix that has all 16 colors in it. And it is kind of time consuming. I do agree with that. There is no quick way to do that in Ruby. Honestly, older days, what I did is I went into job control, created one, and then imported that graphic into Ruby. And then all 16 colors were on there. And I just made that a standard setting. Currently, once you have one set up with all 16 colors, you can just use that and make a new version of it, new copy of it. That's a quick way to do it. But that initial setup to have all 16 colors for quick and easy access does take a few minutes to set up, because you have to literally drag them all in and then set up them individually. And I just typically do it with a number. That's why on my files, when I'm setting up a material, there's all the different numbers you saw on my screen, which aren't like most people's. So unfortunately, no, there's no quick way to do it. But once you have one set up, it can be used and then duplicated for future ones, making future ones easy. But the initial one does take some time. All right, that is our final question. Thank you so much for showing or spending some time with me today. Again, if you have any questions, definitely reach out to myself, anyone on our marketing team, any of our local offices. I thank everyone so much for showing up here today. Any questions, feel free to post them. This will be recorded and posted on our YouTube channel, so for future views, for future viewing enjoyment. Thank you so much for visiting with me today, and have a great day.